Hello everyone, I hope you all are doing well. Today we will be explaining lesson 4.5, proving right triangles congruent, book page number 319. So technically we have to prove that two right triangles are congruent, and for two right triangles to be congruent they must have exactly the same size and shape, and their corresponding angles and corresponding sides are congruent. But with right triangles are a bit special. They have different ways to prove them congruent. So let's check how in this lesson, and let's start listing the objectives of this lesson, and let's move to this slide. So the objective of this lesson, first, by the end of this lesson you should know what is the meaning of congruent right triangles, and by the end of this lesson you have to use the right triangles congruence theorem. So we have new theorems for the right triangle to prove relationships in geometric figures. But before we learn how to prove right triangles congruent, let's have some remarks about the right triangles in the next slide. So a right triangle is a triangle which has one angle that measures 90 degrees, as you see in the figure, and it has this symbol like a small box in the right triangle that measures 90 degrees. Not only that, the side facing the right angle is called the hypotenuse. As you can see in the right triangle shown, C in this case is the hypotenuse since it's the side facing the right angle. Not only that, the sides adjacent to the right angle are called the legs. Side A and side B are the legs of this right triangle. So in each right triangle we have a right angle, we have one hypotenuse, and we have two legs. And if you notice, we have a short leg and a long leg. So again, those are the remarks about a right triangle. So let's move. Right triangle congruence theorem. So now, in order to prove that two right triangles are congruent, they must have exactly the same size and shape. They must be exactly the same. But in order to prove that two right triangles are congruent, there are specific theorems that we have to use for right triangles to prove them congruent. And let's see what are those theorems. So, right triangles congruence theorem. Actually, there are four theorems to prove that right triangles are congruent. Theorem number one, the leg congruence theorem, which is referred by LL. Hypotenuse angle congruence theorem, which is referred by HA. Theorem number three, the leg angle congruence theorem, which is referred by LA. And the last theorem is the hypotenuse leg congruence theorem, which is the HAL. Those are the theorems we are going to use in order to prove that two right triangles are congruent. And let's learn more about each theorem and see how we can use each theorem to prove that right triangles are congruent. So let's start with the first theorem, which is the leg congruence theorem that's referred by LL. So the first theorem in order to prove two right triangles are congruent is the leg congruence theorem. If the legs of one right triangle are congruent, so the two legs of one right triangle are congruent to the corresponding legs of the other right triangle, then the two triangles are congruent by the leg congruence theorem. So in this theorem, the only thing we need is that having two right triangle first. So first we need to make sure that we have two right triangles, and not only that, the legs. So if you see over here, the short leg in the first right triangle must be congruent to the short leg in the second right triangle, and the longer leg in the first right triangle must be congruent to its corresponding long leg in the second right triangle. So the legs of one right triangle are congruent to their corresponding leg of the other right triangle. It means those two right triangles are congruent. If you see in this example, we have AB is congruent to XY, which is the first leg is congruent to its corresponding first leg in the second triangle, and BC is congruent to YC. So the second leg in the first right triangle is congruent to its corresponding leg in the second right triangle. So in this case, we can use the leg congruence theorem to prove that the triangle ABC is congruent to triangle XYZ. So now let's check the second theorem that we can use in order to prove that two right triangles are congruent. So let's check the second slide. If the hypotenuse and the acute angle of one right triangle, so here we have the hypotenuse angle congruence theorem. So from the naming, so we're gonna use the hypotenuse and an angle, and pay attention, the angle we're gonna use here is the acute angle. So we never use the right angle in order to prove, yet the right angle just refers that this triangle is right. So we're gonna use the hypotenuse and the acute angle. So if the hypotenuse and the acute angle of one right triangle are congruent to the hypotenuse and the corresponding acute angle of the other right triangle, then the two triangles are congruent by the hypotenuse angle congruence theorem. So from the naming, it's the hypotenuse angle congruence theorem referred by HA. So let's see what we have in this figure. We have QO is congruent to JK. If you notice, QO is the hypotenuse of the first triangle and JK is the hypotenuse of the second triangle. So we have the hypotenuse in the first triangle is congruent to the hypotenuse in the second triangle. So we need the hypotenuse, check. We also need the acute angle. So we have angle Q is congruent to angle J. So an acute angle in the first right triangle is congruent to its corresponding acute angle in the other right triangle. So in this case, we can use the hypotenuse angle congruence theorem in order to prove that the triangle OPQ is congruent to the triangle KIJ by HA. H means hypotenuse, A means angle, and here we are using the hypotenuse angle congruence theorem. So up to here we covered the first two theorems. We still have two more theorems. Let's move to the third theorem. Leg angle congruence theorem. So from the naming, we have to use the leg and an angle, and pay attention here, we're going to use the acute angle. So if one leg and an acute angle of one right triangle are congruent to the corresponding leg and the corresponding acute angle of the other right triangle, then the two triangles are congruent using the leg angle congruence theorem, which is referred by LA. So let's see what we have in this figure. We have AB congruent to DE. So we have a leg in the first right triangle that's congruent to its corresponding leg in the other right triangle. So the leg is satisfied. We know that the leg in the first right triangle is congruent to the leg in the second right triangle. But in order to use this theorem, we have to use leg and an acute angle, not only the leg. So we need an acute angle, and as you see, angle A is congruent to angle D. So angle A is congruent to its corresponding angle in the other triangle, which is angle D. So here we can use the leg angle congruence theorem in order to prove that the triangle ABC is congruent to the triangle DEF. We still have one more theorem, which is the fourth theorem, which is the hypotenuse leg congruence theorem, which is referred by HL. So here we have hypotenuse and we have a leg to use in order to prove two right triangle congruent. So if the hypotenuse and one leg, so here we have hypotenuse and one leg of one right triangle are congruent to the hypotenuse and the corresponding leg of the other right triangle, then the two right triangles are congruent using the hypotenuse leg congruence theorem, as you see in this case, in this figure, referring those two triangles, we have AB congruent to ED, which is the leg. So the leg AB is congruent to its corresponding leg ED. Also, AC is congruent to EF, so the hypotenuse. So as you see, AC is the hypotenuse. It's the side facing angle B, which is the right. Also, EF is the hypotenuse, since it's the side facing angle D. So we have the hypotenuse in the first triangle congruent to the hypotenuse in the second right triangle, and we have a leg in the first triangle that's congruent to its corresponding leg in the second right triangle. So here we can use the hypotenuse leg congruence theorem in order to prove that triangle ABC is congruent to the triangle EDF. So those are the theorems we're gonna use in order to prove that two right triangles are congruent, and here's the wrap up. So in order to prove that two right triangles are congruent, we have four different theorems. So those are the only theorems. Whenever we see two right triangles and we are asked to prove them congruent, we can use one of those four theorems. So the first theorem is the leg-leg congruence theorem. If the legs of one right triangle are congruent to the corresponding legs of the other right triangle, then the two right triangles are congruent. The abbreviation is the LL. So whenever we see LL, it means the leg-leg congruence theorem. The second theorem is the hypotenuse angle congruence theorem. If the hypotenuse and an acute angle of one triangle are congruent to the hypotenuse and the corresponding acute angle of another right triangle, then the two right triangles are congruent, and this is referred by HA, which is the hypotenuse angle congruence theorem. While the third theorem is the leg angle congruence theorem. So here we have a leg and an angle. So if one leg and an acute angle of one right triangle are congruent to the corresponding leg and corresponding acute angle of another right triangle, then the two triangles are congruent using the LA congruence theorem, which is the third theorem. Now the last theorem is the hypotenuse leg congruence theorem. If the hypotenuse and the leg of one triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the right triangles are congruent, and this theorem is referred by HL. So those are the four theorems. If you can notice, in the first theorem we're gonna need the legs, in the second theorem we're gonna need the hypotenuse and an angle, and pay attention, it's the acute angle. The third theorem we're gonna use a leg and an acute angle, and in the last theorem we're gonna use the hypotenuse and one of the legs. So let's move. So let's practice. Determine whether each pair of triangles is congruent. If yes, include the theorem that applies. So in order to prove those triangles are congruent, we have to use one of the theorems that we learned. So let's start with example number 1. Let's see what we have. We have the hypotenuse in the first triangle is congruent to the hypotenuse in the second right triangle. First, those two triangles are right, so we can use the theorems. So the hypotenuse in the first right triangle is congruent to the hypotenuse in the second right triangle. Not only that, if you can notice that the leg in the first right triangle is congruent to its corresponding leg in the second right triangle. So yes, those two triangles are congruent using the hypotenuse leg congruence theorem, which is referred by HL. In example number 2, let's see what do we have. We have two right triangle. We have two right triangles, and the leg in the first right triangle is congruent to its corresponding leg in the second right triangle. So is this enough in order to prove those two triangles are right? No, this is not enough in order to prove those two triangles are congruent, since the only information we have that leg of one triangle is congruent to its corresponding leg is the second right triangle, and this is not enough in order to prove those two triangles are congruent. Let's move to exercise number 3. As you can see, we have BN is congruent to BM. So we have the leg in the first right triangle is congruent to its corresponding leg in the second right triangle. And if you notice AB is a common leg. So AB is the leg in the first triangle, and also AB is a leg in the second right triangle. So if you notice, we have the two legs in the first right triangle are congruent to their corresponding legs in the second right triangles. So those two triangles are congruent using the leg congruence theorem. And let's check exercise number 4. We have PR congruent to CE. So since PR is the hypotenuse and CE is the hypotenuse, so PR is congruent to CE. So we have the hypotenuse in the first right triangle is congruent to the hypotenuse in the second right triangle. Not only that, we have QR is congruent to DE. So we have a leg in the first right triangle is congruent to its corresponding leg in the second right triangle. So here we have hypotenuse and one leg in one triangle that are congruent to the hypotenuse and the corresponding leg in the second right triangle. So those two triangles are congruent using the hypotenuse leg congruence theorem. So here we can say that triangle PQR is congruent to triangle CDE using the HL or the hypotenuse leg congruence theorem. So let's move to the next slide. So here we have more example. Determine whether each pair of triangle is congruent. If yes, include the theorem. So first of all, we need to make sure that we have to write triangles, and we need to make sure that we are using one of the 4 theorems that we learned about. So let's move. So in this case, let's see what do we have. We have angle O in example number 1. we have angle OMN is congruent to PMN. So we have an acute angle in the first right triangle that's congruent to its corresponding acute angle in the second right triangle. Not only that, if you notice, the hypotenuse in the first right triangle is side MN. And also the hypotenuse in the second right triangle is also side MN, since MN is the side facing angle O and it's also the side facing angle P. So in those two triangles we have a hypotenuse and an acute angle of one right triangle that are congruent to the hypotenuse and the corresponding acute angle in the second right triangle. So those two triangles are congruent using the hypotenuse angle congruence theorem, which referred as HA. Here's we're using the same hypotenuse actually as if those two triangles are reflected by the hypotenuse. So let's move to example number 2. We have the short leg in the first right triangle is congruent to the corresponding short leg in the second right triangle, and we have the long leg is congruent to its corresponding long leg in the second right triangles. So technically we have two legs in the first right triangle that are congruent to their corresponding legs in the second right triangle. So those two triangles are congruent using the leg-leg congruence theorem. So let's move to exercise number 3. First of all, if you notice in exercise number 3, the second triangle we don't have the symbol that tells us that the second triangle is a right triangle. So technically we can't start. We don't have enough information to determine that those are congruent. Technically we can't use any of the theorems that we learned, since the second triangle does not have the symbol, this box. So in this case we cannot tell whether they're congruent or not. Let's look at exercise number 4. Let's check what we have. We have BA is congruent to IH. So the leg in one triangle is congruent to its corresponding leg in the second right triangle, and we have angle A is congruent to angle H. So we have an acute angle of one triangle is congruent to its corresponding acute angle of the second right triangle. So those two triangles are congruent using the leg angle congruence theorem, which is the LA. Let's move. In this example, which pair of corresponding parts need to be congruent to prove that the triangle ABC is congruent to triangle XYZ? Use the indicator theorem. So in example number 3, part 1, we have to prove that the triangle ABC is congruent to triangle XYZ using the theorem HA. HA means the hypotenuse angle congruence theorem. While in example number 3, part 2, we have to prove those two triangles are congruent, but now using another theorem, which is the LL, which is the leg congruence theorem. So let's move and see what do we have. So let's first start with part 1, HA. So we need the hypotenuse and an acute angle of one triangle that should be congruent to the hypotenuse and the corresponding acute angle of the second right triangle. Then we will be using the HA, or the hypotenuse angle congruence theorem, to prove those two triangles are congruent. So let's check what's the hypotenuse in the first triangle. The hypotenuse in triangle ABC is the side AB, while the hypotenuse in the triangle XYZ is the side XY, since it is the side facing angle Z. So technically the first thing we have to do, or the first thing we should be given, is that AB is congruent to XY. So the hypotenuse in the first right triangle must be congruent to the hypotenuse in the second right triangle. So what about the A, or the angle? So we need an acute angle in the first right triangle that's congruent to its corresponding acute angle in the second right triangle. In this case, either you pick angle A or you pick angle B, but pay attention, if you picked angle A, you pick its corresponding angle, which angle X. And if you want to pick angle B, you pick its corresponding angle in the second triangle, which is angle Y. In this case, we picked angle A, so we should be given that angle A is congruent to angle X, which is the corresponding acute angle. Having that, the hypotenuse in the first triangle congruent to the hypotenuse in the second triangle, and an acute angle in the first triangle is congruent to its corresponding acute angle in the second triangle, we can use the HA, or the hypotenuse angle congruence theorem, to prove that triangle ABC is congruent to triangle XYZ. Now let's see part 2. we have to use here the leg congruence theorem. So we need the two legs in the first right triangle should be congruent to their corresponding legs in the second right triangle. So we should have BC congruent to YZ and AC congruent to XZ. Having this as a given, it means that the legs in the first right triangle are congruent to their corresponding legs in the second right triangle. Here we can use the LL congruence theorem in order to prove that ABC is congruent to XYZ. Determine whether the next, now let's move to example number 4. Determine whether the next pair of right triangles are congruent. If yes, include the theorem that applies. First, let's see what do we have. We have both of them are right triangles. We have the leg in the first right triangle is congruent to its corresponding leg in the second right triangle, and we have an acute angle in the first right triangle that's congruent to its corresponding acute angle in the second right triangle. So here we're technically using leg angle congruence theorem. So let's see. So yes, the pair of triangles shown are congruent because the corresponding legs are congruent and the corresponding acute angle are congruent. So then the two triangles are congruent using the leg angle congruence theorem, since we have leg and an acute angle in the first triangle that are congruent to the corresponding leg and corresponding acute angle in the second right triangle. So here we're using the leg angle congruence theorem in order to prove those two triangles are congruent. So let's move the slide. So this is the guided practice example number 1, book page number 320, right triangle congruence theorem. So here we're gonna use the theorem to determine whether each pair of triangles is congruent or not. We're gonna solve each part aside. So here we have to determine whether each pair of triangles is congruent. If yes, include the theorem that we used. Let's look at example number A. We have leg in the first right triangle that's congruent to its corresponding leg in the second right triangle. And we have an acute angle in the first right triangle that's congruent to its corresponding acute angle in the second right triangle. So here we're using the leg and an acute angle. So it's the LA or leg angle congruence theorem. So one leg and an acute angle of one right triangle are congruent to the corresponding leg and corresponding acute angle in the other right triangle. It means here the two triangles are congruent using the leg angle congruence theorem. Let's move to part B, and it's the same question. We have to determine whether each pair of triangles are congruent, and if yes, we have to include the theorem that we actually used. Let's see what do we have in those two right triangles. We have that the two acute angles in the first right triangle are congruent to their corresponding acute angle in the second right triangle, but we don't have a theorem that tells us if the acute angle in the first right triangle are congruent to their corresponding acute angle in the second triangle. It means those two triangles are congruent. So we don't have enough information to determine whether those two triangles are congruent. And in order to determine those are congruent or not, we need to have at least one of the corresponding sides are congruent or one of the corresponding legs are congruent. So in part B, we don't have enough information to determine whether those are congruent or not. Let's move. So this is example number 1, guided practice. It's the same question. We have to determine whether each pair of triangles are congruent. If yes, we have to include the theorem or the postulate we actually used. So let's see what we have in this figure. We have the leg in the first right triangle is congruent to the leg in the second right triangle. Not only that, both triangles share the same hypotenuse. So the hypotenuse in the first right triangle is the same as the hypotenuse in the second right triangle. So we have hypotenuse in the first right triangle that's congruent to the hypotenuse in the second right triangle, and a leg in the first right triangle that's congruent to its corresponding leg in the second right triangle. So we have a hypotenuse and a leg in one triangle that's congruent to the hypotenuse and the corresponding leg in the second right triangle. So those two triangles are congruent by the hypotenuse leg congruence theorem. As we mentioned, one leg of one right triangle is congruent to the corresponding leg in the other right triangle, and the two right triangles share the same hypotenuse, so the hypotenuse of the first is same or is congruent to the hypotenuse of the second right triangle. Up to here, this is our lesson. Thank you for listening and have a nice day.